If you've got any questions, you can hit me with it. But with 2G, you're putting in stuff that we have done before. So find all real polynomials of degree 3 with zeros. What can you remember about this? If 1 take 3i is a 0, then 1 plus 3i is a 0. And then what are you using? Sum and product. Okay? When we're talking about question 2, we've got P of 1 equals P of 2 plus I equals 0. What are we on about there?
P2 minus I is 0.
Hang on. Is it telling you the first one? What's that P of 1 saying?
P2, oh, that's just saying the answer to, oh, P1 equals 0.
Yes, it's saying P1 equals 0, but we interpret that to be what? 1 is a 0, therefore? Ooh, yes, okay, 2 plus I is 0, so I'm going with this one. Wouldn't that mean that x or z, right, x take 1 is a factor. As you were saying, if 2 plus I is a 0, then we're saying 2 take I is also a 0, it's a conjugate. And so once again, we've got the sum would be 4, the product would be 5, and that would give me, keep the sign, sorry, reverse the sign, that's what I meant to say, and keep the sign. It's a cubic. Am I good with that? No. No, Nanette, because there could be infinitely many. So we have to put the A out the front, and A can't equal 0. This would all be done and dusted if we did not have another piece of information. But because we have this, P of 0 equals minus 20, what would you do? You would sub wherever x is, or z, whatever you used, wherever x is, you replace it with 0, and you should get minus 20, which means you should be able to solve for A. But this is stuff we've already done. It's just pulling it all together. Agreed? I'm not up to all of this, and she's going on to the next bit. Don't worry. You'll see it. It's quite nice, so trust me, said the spider to the fly. If you look at the program, there's more graphs and stuff, but I'm saying we're not doing any of that because it should be, you don't have to worry about that, it should be common knowledge. All right, so this stuff here, can you sketch graphs? You're going to be looking at that in methods. So I don't think that we need to do this. You've got your calculator. How would you sketch this? You could put it in your calculator. How would you just do a quick sketch without using a calculator? Sorry, I need hands up, if you don't mind. We are a small group, but yeah. Now, you say find the intercepts. We can state them, 1, minus 3, and minus 2, and then we would use A. Don't need to. If we're just doing a quick sketch, I don't need you to label, but well done. Yes, Maxmin using calc, but sign diagram. All right, and you've done those in methods. If you're unsure, let me know. And it just goes on. They give you graphs. So I'm really not going to do this stuff. Is that okay? The bit that I wanted to move on to was our first part of this, technically, the first part of the topic is functions. And as I said, it's all about notation. Notation. And you can write this down, or you could just go, yeah, I'm not ready to put it in my book yet. When I finish what I needed to, I will do it. Have we seen any of this before? Yep, we should have. So I like to call it fog. That's just a f of g of x. So I will always write it like this. Okay? And it's telling you, who can tell us, what is it saying? It's speaking to you. Listen very carefully. Forming the g function. Yes. I sort of just go, this is telling me where go to your f function, and wherever x is, replace it with g of x. Okay, and the big thing to know is that will fog, f of g of x, will that equal goff, g of f of x? They're not always the same, right? And most of the time they're not. So this little exercise just goes on about using that notation, okay? So again, something that you looked at last year. F of g of x, again, I see this, I will always write it like this. Some students don't need to, but anyway, I do. Wherever the g of x is, you sub it, And now go to your f function wherever x is, replace. Simples? They're going to ask you about the domain and the range. So remind me, what is domain?
The range of x
You can't say, yeah, it's hard to say.
set of x values.
So your domain is all the x values where the function is defined. I should have the function, but anyway, I'm writing quickly. So, when are functions undefined? Think of some functions where we go, it wouldn't exist. Got one, yep?
Tangential functions?
Yes, so when you say tangential function, so the tangent function, we end up having these things called asymptotes, excellent, and it will look like why do these asymptotes appear in the tangent function? Pardon? Yes, why is there no solution for that in the tangent function?
It's sin x over cos x. So cos x.
Right, so your tan function, I'm just doing it up here, and I'm trying to make a point, but anyway, is sine over cosine, right? And you will find that your asymptotes appear where the cosine is equal to 0. And why is that? Because we...
Well, because of the radial function. When
Yep, absolutely. I'm thinking more of, why does it matter that that is equal to 0? Because we cannot divide anything by 0. So it's not just a tangent function. It could be, 1 over x. It could be 3 over x take 7. Well, x couldn't be 7 because it would then be undefined. So when do we have functions? 1, you cannot divide. So when we've got fractions, the denominator cannot equal 0. And that's going to restrict our domain. Does that make sense? What's another situation where our domain or a function might be restricted / undefined? Square root functions. What's so big about square roots? Right, when we've got square root x, you cannot square root a negative. So x has to be greater than or equal to 0. Can we think of some other situations where we go, you ever get that error on your calculator and you go, can't do. Exponential? How so?
Wait, no, I don't. I was thinking about something.
Right, logarithmic function. So when we've got ln of, I'm going to say a instead of x, but what's so big about the thingy? We cannot log a negative value, but we cannot log 0. So for this one, we would have a must be greater than, so not equal to, but greater than. So when you're going through and you look and you sub in and it will then say, can we find out when a function is defined or not? You have to check. If it's a fraction, check out the denominator. For what values does it equal x? And then you say, niet. No, net. That makes sense? So we're just going to do one little one just to remind you of some of your notation. There's a couple of others and you'll discover those as they come along. So sometimes with, I'm not going to put it on there, but with sine and cosine, you've got a limit when we're talking about the inverses. What's the limit for inverses, Kaya, with sine and cosine? Sine and cosine, we've got a limit there when we're talking about the inverses. And you've seen it on your calculator when you first started in year 9, right? So when we've got, that's our typical sine, it goes between 1 and -1. So if you try and go sine to the -1 of anything in between 1 and -1, you're good to go. But if you tried to do it of, should have gone a little bit higher, sorry about my poor writing. If you tried to do it of inverse sine of 2 or 1.1 or 1 point whatever, you will get error. Not possible because the function doesn't exist there. we don't need to worry about that, but I'm just saying those aren't the only possible undefined situations. And now, how do we write them as undefined? Are we happy with our notation? Like if I wanted to say it's in between, x has to be in between two values, because you'd be doing that in methods with your sign diagram. So I'm not going to interrupt. I'll come around and see people, because it didn't sound like there were any major questions.